Okay, so our learning goal for this lesson is to understand periodic function transformations. Now you'll remember from last year that a periodic function can be a sine curve like this one. We'll also take a look at cosine curves like this one. First of all though, let's take a look at our sine curve. Now you should remember from last year that a sine curve can really be written just simply as y equals sine x. Now what we're looking at here in this function is y equals sine x. Now a couple of things about this function. It has an amplitude, that is a distance from the x-axis up to the top of 1. That's to be expected from y equals sine x. It also has, just move that back there, it also has a period, that is the time it takes to repeat. So you can see it starts here at 0, goes up, down, and back up to its starting position. It has a period of 2 pi. That is the time it takes to repeat is 2 pi. That's measured in radians, 2 pi radians. So up, down, up in 2 pi, up, down, up in 2 pi, again and again and again. So that's y equals sine x. You'll also see that the x-axis runs through the middle of it, and in the case of sine x, it starts at the origin, 0, 0. Now, you should also remember, just move this up a little bit, you should also remember that a sine curve can be modeled by this function, y equals a sine b x plus c plus d. Now, a, b, c, and d are all constants. They're all numbers of some sort. In this function here, y equals just sine x, the a value is actually 1, and the b value is actually 1 as well. The c value and the d value are 0 and 0. You can see that up here, y equals 1 sine 1x plus 0 plus 0. That's our function here right now. What we're going to do is change that function in a number of different ways. First of all, let's work on the a value and see what the a value does when I shift it. I'm going to use this slider over here. To shift it. Let's see what happens. As we move the a value up to 2, we can see that the amplitude of this thing has increased. It's gone from an amplitude of 1 up to an amplitude of 2. Now if I increase that a value further, we can see again that amplitude's increased. An a value of 1 has gone up to an a value of 3. So in our notes here, we can say that our a value controls the amplitude. The higher the a value, the larger our amplitude is going to be. And there's a direct correlation between that a value and that amplitude. If the a value is 3, the amplitude will be 3. If the a value is 5, the amplitude will be 5, so on and so forth. Let's quickly look at what happens when I shift that a value into negative territory. That's an a value of 1, back at where we started. Lower, 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 lower. Okay, let's move all the way to a negative 1. You should be able to see here that what's happened is it's flipped. It's flipped about in the x-axis. It used to be like that, starting at 0 and moving upwards from there. Now it's starting from 0 and moving downwards from there. So a controls the amplitude, and a negative a flips the function. Well, let's use the technical term here. Reflects the function in the x-axis. So it reflects it about the x-axis. I'm just going to move that a value back now. Okay, that's our a value dealt with. A controls the amplitude. It will also reflect the function in the x-axis. I'm going to ignore the b value for a moment. I'm going to move straight to the d value. The d value is probably the easiest to understand what it does, how it works. Let's take a look at what the d value does. Just watch our function closely. I'm going to move our d value up. Okay, you can see that that's a d value of 2, so our function is now y equals sine x and a plus 2 on the end. You can see that it's moved our axis of symmetry. It's actually created a vertical shift. It's moved our function from here up to here, 2 units. Now if we make our d value negative, you can see that it shifts it downwards. So pretty obvious here, the d value will move it up and the d value will move it down depending on whether it's positive or negative. We'll take a break there, and in the next video we'll take a look at what the b value and the c value does.